So there are a couple ways that you go about doing this problem. You could go ahead and simplify them as separate expressions, separate terms. My recommendation would be, I notice that these are both square roots, and we know from one of our properties of radicals, if you look at those notes, that if the type of radical is the same, we are able to combine everything into one large radical. For example, if I had asked you to take the square root of 3 times the square root of 4, you guys hopefully know that that is the same thing as the square root of 12. Meaning since they're both a square root, 3 times 4 is 12, that's all we have to do. So knowing that, I would prefer to just combine all of this into one term, and then I will look to see what I can simplify, what I can pull outside of the radical, things like that. So the 5 is outside the radical, it's just going to stay where it is, nothing special going on there. Inside a square root, I now want to take a to the third, b to the fifth times 4ab. Well, the 4 is just 4. There's no other numbers for me to multiply it to. But I have an a to the third and an a, or in other words, an a to the first. When we multiply like bases, we are supposed to add the exponents. So a to the third times a to the first would be a to the fourth, because 3 plus 1 is 4. Same idea with the b values. I have a b to the fifth and a b to the first. So 5 plus 1 would give us b to the sixth. So now I want to see if I can square root those, meaning I'm looking to square root 4, I'm looking to square root a to the fourth, and I'm looking to square root b to the sixth. Well, certainly the square root of 4 is 2. So right now I have 5 times 2 that are both outside the radical. Next up, I need to square root a to the fourth. So you can do that one of two ways. You could recognize that a square root represents a 1/2 exponent, and so we would have a to the 4 over 2, which is simply a squared. You could also do the square root of a to the fourth by doing a factor tree, noting that a to the fourth means we have 4 a's, and that a square root means I'm looking for pairs. So I can pull 2 a's out, and a times a is also a squared. Either way, one way or another, you should get that the square root of a to the fourth is a squared. Likewise, when we do the square root of b to the sixth, you again have two options. You could look at it in fraction form, which would be b to the 6/2, giving us b to the third. Or you can do a factor tree for b to the sixth, which means you would have 6 b's, which would give us 3 pairs. So again, we'd pull 3 b's out, giving us b to the third. So it turns out there's actually nothing left inside the radical. If we'd had like b to the seventh, then we would have had an extra b inside the square root, but in this case, everything canceled out or was pulled outside the radical perfectly. So 5 times 2 is 10, and my answer is 10a squared b to the third.